Welcome to the viewers. Now we discuss a few examples how to use the convolution theorem. At first, recall the expressions of the convolution theorem in Laplace transform. That's Laplace transform of psi t. In the earlier classes, we write it here. That is Laplace transform of psi t. That will be g1p and g2p, where psi t is integral 0 to t g1 tau and g2 t minus tau d tau. We writing this, so it's clear that psi t will be L inverse of g1p and g2p, and clear using p here as a complex parameter in the Laplace transform. No matter for that, sometimes if we use s or sometimes if we use p, both have the same meaning, no problem for that. Now it's obviously clear that g1t will be L inverse of g1p and g2t will be L inverse Laplace transform of this result. Now with this help of these results we apply to find few inverse Laplace transform. Let us see by an examples. Example number 1. To find the value of L inverse p by p square plus a square whole square. But from here we observe that let L inverse p by p square plus a square whole square, that can be written as L inverse of p by p square plus a square multiplied 1 by p square plus a square. So it is obviously clear L inverse of g1p and g2p, if we consider it, where g1p that will be p by p square plus a square and g2p will be 1 by p square plus a square. And if we make it shape, because it's easily observed that g2p is equal to 1 by p square plus a square, so we doesn't convert any type of form, standard form in the Laplace transform, any type of formula, so we have to adjust how to observe it. And we observed it, Laplace transform of sin t will be, sin of at will be a by p square plus a square, but here only 1 we find, so if we put it here a, then we make it same, so it will be divided by a, then it remains same quantity, so we have to adjust with the factor of 1 by a and a. Now let us proceed. Now g1t will be L inverse of p by p square plus a square. It's clear, so it will be cos of 80, no problem for that. Now for g2t, what we will have? We will have L inverse of 1 by a, that's called g2t, a by p square plus a square, that will be 1 by a, L inverse of a by p square plus a square. So it will be 1 by a sine of at. It's a standard result. Therefore, L inverse of p by p square plus a square whole square, that will be, here we apply the convolution theorem, integral 0 to t. In the earlier stages we apply here psi t in this way, that is 0 to t. Formula is, what will be the formula? Psi t 0 to t g1 tau. Here g1 t will be cos of at, so g1 tau will be cos of a tau, that will be cos of a tau. We apply here the formula g1 t, we find g1 tau, that will be cos of a tau. Next terms for g2 t minus tau, so here g2 t is this 1 by a sine of at, that is g2 t minus tau will be 1 by sine a into t minus tau, and we substitute it 1 by multiply 1 by a sine a t minus tau d tau is equal to, we write here the product formula in general trigonometry, 1 by twice a integral 0 to t 2 cos of a tau sine of a into t minus tau d tau. Now simply trigonometrical formula in school level, 1 by twice a 0 to t, it will be, if we break, that is sine of this, adding this quantity, that is if we add it, a tau will be cancelled, then it will be this plus this. So if we break these terms, this will be sine what happens there, twice sine a tau into sine a into t plus tau. So the result will be, here is the getter of the cos cosine angle, so it will be sine sum, so sine of here it will be a tau plus at minus a tau minus sine of a tau minus at plus a tau. If we repeat these terms, one by twice a 0 to t, it will be sine of at plus it will be minus sine 2a tau minus at and d tau. So it's obvious result. Break the integration terms, 0 to t sine of at d tau minus 1 by twice a 0 to t sine of twice a tau minus at d tau, and it's obvious and clear. This term treated as constant, sine of at 0 to 2t d tau, and 1 by t here with respect to tau, so it treated as constant, that will be difference of cosine, that is 1 by 4a square, and cos of twice a tau minus at, and this ranging from 0 to t. If we put it t by 2a sine of at, and if we put it here, and that will be cos at minus cos at, that will be 0, and same term that will be cancelled, and it's clear. So it will be t by twice a sine of at. Now in this way we find out L inverse Laplace inverse of the Laplace transform of p by p square plus a square whole square is equal to t by twice a sine of at. Now if we consider another example 2, L inverse of 1 by root p into p minus 1. Here if we consider here L inverse of g1p and g2p, where g1p is equal to 1 by root p and g2p is equal to 1 by p minus 1. So here g1t will be L inverse of 1 by p to the power, here half is written as minus half plus 1 in this way. Now it will be formula of L inverse of 1 by p to the power n plus 1, that is n factorial by n. That means here we can't write in this way, so we can write in the form of a gamma function. What will be the result? Result will be 1 by n factorial, but we can write because it's a fractional part, so we are writing here t to the power minus half t to the power n by gamma of n plus 1 formula, that will be n will be minus half plus 1. In this way, gamma n plus 1, which I have discussed in the earlier theorem, that will be t to the power minus half, that is gamma half. What will be the gamma half? Gamma half result will be root pi, and it is calculated, and how to calculate it, that's described in the beta gamma function clearly. I don't discuss it in these videos because this is not possible, and this is not possible to find out here, not appropriate. But we use simply the calculations and the result of the calculation, better to say. And it will be t to the power minus half, and gamma half will be root pi, so here it will be 1 by root pi t. And now g2t, that will be L inverse of, here in this notation, fixed notation we apply, 1 by p minus 1. So by the shifting theorem we have e to the power t, because it will be minus 1, that's why e to the power t, L inverse of 1 by p. So it's clear that e to the power t into 1, so it will be e to the power t. Now using convolution theorem, therefore L inverse of 1 by root p into p minus 1, that will be integral 0 to t 1 by root over of pi t e to the power t minus tau, ft into e to the power t minus tau, that will be pi t. Here it will be gt, so g tau, that means here t tau into e to the power that will be t minus tau, so it will be t minus tau d tau. So what is the constant term treated here? E to the power t. So we are writing outside the integral e to the power t by root pi, and we write inside 0 to t 1 by root tau e to the power minus tau d tau. This will be the final answer of evaluation. And so already we evaluate how to find out the L inverse of this using convolution theorem. Now we end our classes today. Thank you.